Hi, I'm Tawanda Ewing, and this is Mindfull, a series where I draw from science, engineering, and personal experiences to give you an interesting perspective on everyday life. I hope you enjoy it, and let me know what you think in the comments.
In 1943, Thomas Watson, the president of IBM at the time, predicted that there would be a total world market of maybe 5 computers. He could have never imagined that we would be at a point where billions of computers are used every day. But you can't really blame him for this prediction, because the computer he was referring to was a machine half the size of a basketball court and could only do about 500 calculations per second. 76 years later, we have smartphones that can perform about 34 billion calculations per second, and supercomputers the size of a full basketball court that can perform 200 quadrillion calculations per second. All this in one human lifetime. Now we find ourselves at the beginning of another computing technology that might change the way we live in unimaginable ways. I'm talking about quantum computers. You might have heard of them, but don't really get what all the fuss is about. So let's check them out. Firstly, the word quantum is referring to the very tiny and strange world of quantum physics. Thanks to some very useful quantum phenomenon, we can build quantum computers and other quantum devices that seem like something straight out of a science fiction movie. The two phenomena of interest are entanglement and superposition. If you watched episode 3 of Mindfull, then this won't be your first encounter with the concept. When we refer to superposition in quantum physics, it's an understanding that subatomic particles, like electrons, are not solid objects, but rather exist as a wave of possibilities that only solidifies when observed. If you understand that, then the next step is to realize that quantum computers use qubits, which are quantum bits that exist in a state of superposition, and allow quantum computers to search through an infinite set of possibilities and return the correct answer. If I just lost you there, let's see if this example of a quantum computer performing a simple calculation helps. Let's say you had 4 cards and one of them was a queen. Then you decide to play a game where you put all the cards face down and make a computer guess which card is the queen. A classical computer will take 2 tries on average to find the queen, while on the other hand, a quantum computer will do it in just 1 attempt every single time. Not sometimes, not most of the times, but I literally mean every single time. Try this example yourself by searching quantum card test IBM on the internet. So picking 1 card out of 4 correctly every single time is not something easy, and the question is, how does a quantum computer pull this one off? Well, unlike traditional computers that can only search 1 possibility at a time, quantum computers search all possibilities simultaneously. So a simple game like the card test is child's play to a quantum computer. Notice that the computing game has changed from how many calculations can I do every second to how many possibilities can I search at once. And roughly speaking, the more quantum bits or qubits you have in a quantum computer, the more possibilities you can search at once. The question now is, so what? What can we do with this power that we couldn't do before? Well, one big thing is simulations, especially those of molecules that enable us to discover new medicines. Molecules follow the rules of quantum physics, so it makes sense that simulating them on a quantum computer would yield more accurate results in far less time. Cybersecurity is also something that will be affected by quantum computers, but in a negative sense, because quantum computers will be able to crack encryptions in seconds that would take a classical computer hundreds of years to do the same. A solution for this problem would be quantum communication using entangled particles. Chinese scientists have already conducted an experiment that successfully proved the concept. So if you want to find out more, just look up quantum communications. These are just some of the things that we can think of now, but just like classical computers, there is no telling how impactful quantum computers will be. If we let our imagination run wild, maybe we can make a lucky guess. I mean, at the root of it all, what we have here is a machine that looks at the inherent uncertainty of our world and finds certainty. With powerful enough quantum computers, simulating entire worlds just like our own might actually be on the table. And once we pull that off, how does it affect the way we understand our own world? Think of the kind of insights we could gain about our past, present, and even future if we could run those kinds of simulations. Sometimes what we can pull off as humans just amazes me, because about 12,000 years ago we figured out that if we put seeds in the ground, we can grow food whenever we want. And now you're listening to me talk about quantum computers through a screen. It's like the only thing that can stop us is us, and we're also surprisingly good at that. But until next time, stay mindful.
This video was brought to you by Umoja Urban Culture. Umoja Urban Culture is a store based in South Africa that specializes in Rasta wares and accessories. For more information, you can visit the store website at www.umojaurbanculture.co.za.